Welcome everyone, my name is Sagar and I will be the mentor for your complete Android course. So this is the very first video of our course, and in this particular video we are gonna see all the prerequisites that you must do before starting with the course. So in this video we are gonna learn about Kotlin Basics, oops in Kotlin, DDL and DML commands for SQL, and also we are gonna see the installation of Android Studio. So without making any further ado, let's get started. So before starting with the Kotlin basics, let me just tell you why we choose Kotlin as the primary language for this course. So previously we were using Java language for developing Android apps, and everything was just fine. But only Android developers know that there were so many problems with the language. The first one was it was not readable enough, and you also know that thing. If you ever worked with Java language, then you know we have to everywhere write our boilerplate code. And the second thing was it was not that much easy and effective to do multi-threading in Java. So after noticing all these problems back there in 2019, Google just announced that Kotlin will be the primary language for Android development. And definitely it was a very good decision because Kotlin comes with so many advantages. So you might be thinking that if all the previous Android applications were already made in Java, then why should we make more efforts to convert our codebase into Kotlin? It will obviously take more efforts, but actually that is not the case. You actually don't need to convert your whole codebase into Kotlin at once. You can just do it one step at a time. That means you can change just one functionality and you can just keep the other parts of your application in Java language. So that is the beauty of Kotlin. It is interoperable with Java. And there are also so many other benefits to use Kotlin in your project. The first one is it is expressive and concise language. That means now you don't have to write all the boilerplate code that you were writing in Java language. And the second one is it supports more safety in your code. That means there is a specific feature in Kotlin language that will help you to prevent null pointer exception. So using this, you can just define for your every single variable whether they can contain null value or not. And the third main feature of Kotlin is actually it is a superpower, the superpower of coroutines. So whenever we have to do some background task, we don't need to necessarily create a thread for this. We can just create a Kotlin coroutine, and you can just consider it as a mini thread, but it is more powerful than that. I mean, just think of it. You can just save a lot of your resources if you are not creating a thread for some basic functionality. And the last and latest feature of Kotlin language is Jetpack Compose. So Jetpack Compose is a UI toolkit that is built on Kotlin language. But in this course, we are just gonna use views and XML files to create our UI. So now let me just show you how Kotlin is interoperable with Java and how it compiles. So how actually Kotlin language compiles and how it is interoperable with Java. So first of all, we have some Kotlin file that will have extension of .kt. So in our Java language, when we create some file, so we also have to create a public class in that file with the same name of the file, right? So the Java file have the extension .java, and in our Kotlin file, it is not necessary that we are always creating a class with the same name. So you can just write your function and do all the stuff, and it is not necessary that you have to create a class in this. So after that, what a Kotlin compiler will do. So Kotlin compiler is Kotlin C. Like in Java, we have Java compiler, that is Java C. So Kotlin compiler will automatically generate a public class from that file. And remember that thing, it is a very important concept. The class that will be generated by this compiler will be a final class. And you know that we just cannot extend our final class. So if you want to extend some class, then that class should be marked as open class. So we will just see that thing later in the video. So what a Kotlin compiler will do. So it will just take this .kt file and it will convert it into .class file of Java language. And that is what Java compiler also do. It takes our .java file and it converts it into bytecode that have .class file. And after that, we can just run this .class file in our JVM. So our Kotlin file also run on JVM. Remember that thing? So JVM, that is your Java virtual machine. So that means first of all, you have to install a JDK. So that can also means Kotlin is the evolution of Java language. I don't know. I will just leave that thing to you. So now we will just see the basics of Kotlin language, and if you are already comfortable with any object-oriented language like Java or C++, then it will be very easy for you. So just you have to remember the syntax and you are good to go. So first of all, just write here play.kotlinlang.org and you will be at this page. So this is the online Kotlin compiler, which is officially by Kotlin language. And here we are just gonna learn all the Kotlin basics. So first of all, let us just start with the program entry point, and that is the main function. So like in our Java language and also in C++ language, we have our main method. So like in this case, we have our main function. So in Kotlin, we can just write it as this. We don't have to even create a class for this. We can just write here fun. So fun is the keyword that we have to use to create our functions, and then main. So remember that thing in Java, we have to write here inside our main method, we have an array of strings, and we can also write it here. So that will be args. So after that, so this is the name of our variable, and the variable is of array of strings. So that is how we write our input, and we can just write here our program arguments, and they will be stored here. So there are two ways how we can write our main method. The one is this with this array of strings, and after that, this is the second one with no arguments. And after that, we can just write everything inside this block. And suppose I have to print here hello world, and I will just run this. So you can see we are printing it, and it will also work the same as our Java do. So this is the normal print method like we also have in Java, system.out.print. And if you also want to print a line with it, so print ln like we have in Java. Let me also print here something else. Suppose I am printing 1. So in first line it will print hello world, and in second line it is printing 1. So that is a very basic thing. And after that, let us just create more functions, and let us see how function work in Kotlin. So this one is the keyword that we have to use to create our functions in Kotlin. And after that, the name of our function, and then this parentheses. Now where we have to specify our return type. So we have to write it here. So double colon, and after that the return type. So it can be integer, it can be boolean, it can be string, or anything else. So let me just create another function here. So fun, that will be sum. After that parentheses, and I am defining here it will be integer type. And after that these curly braces. So like in Java, if we have to return anything, we can just use this return keyword. And what do we have to return? First of all, let me just write here some arguments. So I will just define here two integer parameters, and that will be a of type int, and after that with comma, this b that is also of type int. So this is how we have to define our parameters in our Kotlin language. So a, that is the variable name, and after that this double colon, and after these we have to define our type, whether it is an integer or string, and we can just return a plus b. So let me just call this main some function here inside our main, and I will just print the output. So I will just pass here 1 and 2, so it should return me 3. So 1 plus 2 will be 3 here, and we will just print 3 as an integer. And there is also a very handy thing that we can use with our function. So if our function is of one line, then we can create our function as an expression. So instead of writing this whole thing, we can just write it here. This will be equal to a plus b. So if we are calling this function, then it will take these two parameters, and we'll just add it and return. So this is the exact same thing what we were doing previously. So let me now just check it. So it is the same output here. And now let me just talk about the return type. So what is the return type of this main method? Remember in Java, what is the return type of our main method? Public static void main, right? So the return type of our main method in Java was void. And in Kotlin, void will be treated as this unit. So unit will be redundant here. That means we don't have to specify it. If we are not specifying anything, that means it will be void. And unit is similar to void. So let me just try to run this, and it is giving the same output, and there is nothing changed. And after this, let me just quickly move to creating variables. So how can we write comments in Kotlin? It is exact same thing as Java. So how can we define a variable in our Java language? So int a equal to then value and then semicolon. So it is something like this, right? But in our Kotlin language, first of all, we have to define whether it is a mutable value or it is a fixed value. So if it is a mutable value, that means we have to change it in our future. So we can just write here var. So var means variable, and if it is a non-mutable value, that means we have to never change it. So we can just define that as val. And if we have to write here a, and this a is the variable name, and after that we have to define the type of this variable. So with this double colon, I have to define that this is an integer, and then assignment operator, and then 1. So it is not necessary that you have to put here semicolon or not. That is totally your choice. So this is how we can define a mutable value, and after this line we can also change it. And let me just print it also, print a. And if we have to define an immutable value, then we have to write here val, and after that name. This will be also of type integer. And let me just change it. Let me just try to change it. So if it is 3, and I am printing it, this line will give us a compilation error because we just cannot change our values. And if we have to make this variable changeable, then we have to write here var instead of val. But I will just do this, and it will just show you compilation error. You can see val cannot be reassigned. So I will just comment this line and let me try it. So it will print me 2 2, and you can see 2 for A and 2 for B. Also, there is a shortcut that you don't have to define here the type. So Kotlin is a statically typed language and it will just define the type here. So when we are assigning the value to some variable, so Kotlin will automatically check what is the type of this value. So it is here an integer. So this B variable will be of type integer and it will just give the same output. And let me just do the same thing for our A variable and let me try to change the type. So first of all, A was of type integer. You can see here one is an integer. So this A will be always integer. And after that, when I try to change it to string, so this is now a string value and it is also same as in other languages. So let me check here. So it will just give us a compilation error, that is type mismatch. And after that, let me just do some things with strings. So let me just define a value of string here. So s, and I will not define the type here. So this is a string, and if we also have some other values, something like this, well, a equal to 1, and we have to use this a inside the value of this s. So how can we use it? So in our Java language we can just do like this, or we can also use here the concat operation, concat method of string class. But in Kotlin we don't have to do this. We can just write here, this is a, then this ampersand symbol and this a. So now the value of this s will be, this is a, after that 1. So let me just try to check it, print s. So now you can see this is the same output. And if we have to use some multiple variables like this, so if there is some second value that is 2 and I have to write here expression, so I can just use here curly braces and I can write here a plus b. So what this will return, this is a 3. So you can see here, this is just something that is different from our other languages. And other than this, the string class in Kotlin also have some methods like in Java, and we will just see some of them using our IDE. So after this, let me just move to loops. So let me just write here a multi-line comment. So this forward slash and star. So this is how we can write multi-line comment in Kotlin. And how we were writing a for loop in our Java language. For, then this parentheses, and I equal to 0, I should be less than 10, I plus plus. So this was the thing, right? So here I should be less than 10. And after that, these parentheses, right? So there is a lot of thing to write, but in Kotlin, this is a very simple thing. We just have to write here for, and after that, now we have to write a variable that will contain all the values. So it is here I, and then in keyword. So in means after that we have to write a collection, and the collection will be 1 to 10. This. So this is ranges. So this is a very beautiful concept of Kotlin language, and we can just write here ranges. So that means 1 to 10. So it will just print all the numbers between 1 to 10. Print I. So let me just see the output, and you can see here 1 to 10 all the numbers. Suppose I have to do something else here. Suppose I have to write here, instead of writing I plus plus, I have to write here I plus equal to 2 or I equal to I plus 2. That means I am jumping 2 times. So when I have to make a jump on my variable, then I can write here step 2. So that means this variable will take a step of 2. So let me just write here this print ln so that we can have all numbers in different line. So you can see here 1, and after that a jump of 2. So we'll be at 3 and we will skip 2, and then 5, then 7, then 9. And suppose for some another example, I have to write here, instead of starting from 0, I have to start from 10, and this should be greater than 0. And every time I have to reduce this value. So how can we write this in our Kotlin? We just cannot do it like this. We cannot do this, okay? This will just give us nothing. We have to write here down to. So that means we are starting from 10 and we have to go down to 1, and we don't have to make any step. So let me just try it. And you can see we are printing all the 10 numbers. So there are also a lot more amazing features of Kotlin language. I just cannot cover all of them in one video. So what you can do is go to official Kotlin documentation right from here, and you can just search all of them. So after this, we also have a while loop. The syntax of while loop is almost similar. I should be less than 10. And after that, this braces. So that is similar to our other languages. And after that, we have conditional statements. So in Java, we have to write here if, then these parentheses, and after that, these curly braces. So this is exact same in our Kotlin language. We have to write here a. If 1 is less than 2, then we have to do something else, something else. So this is same as in other languages. So after conditional statements, we have switch statement. So what is switch statement in Java language? So we have to write here switch, and then in this parenthesis some value, and after that the different values, different cases that we can have. So we have to define here all the cases. Case 1, then this double colon, then case 2. We have to define all the cases. So we have the keyword switch, but in our Kotlin language we have some another keyword, and that is here when keyword, when. And after that we have to write some expression. So I will write here 2, a equal to 2. So I will write here when a. So after these curly braces, we can simply write here if it is 1, then we have to print. I will just print here 1. And if it is 2, then this arrow symbol. So this is here minus, and this is a right shift. And after that, print 2. So that's it. Or also one more thing, we also have here a default block, right? We have a default keyword, and after that we can just write default value if it is not falling in any case. So here we have a else block. So this is the same thing as our default. So we can just print here none. And let me just check here now. So it is printing here too. Suppose I am writing the value of a as 3, so it should print me none. And you can see here. So Kotlin is a very easy language. So after this, let me now just move to list in Kotlin. So how can we define a list in Kotlin? So I just have to write here, this is a value. That means it will not change. I will just call it list, and it is a list of, and I have to define here some values. So A, and after that B, and then C. So that's it. And we can also traverse here like a for each loop that we also have in Java. I will just write here A in list. So LIS, and I can just print this A. So it will print me ABC. And you can see here. Also, when we are working with collection, so this list is also a collection, we can just use here some lambda expressions. So that means, suppose for example, I am writing here some valid things, apple and banana, and suppose here avocado, and then some other random fruit. So lambda expressions are like a function, but it is more than that. We can just use these expressions to filter or map our collections. So suppose for this list dot, then I can use a filter. So it is like a filter function, but it is not a function, it is a lambda expression. So inside this function, I have to define what value do I have to filter in this list. So I will just define it because it is expression. So it is like a lambda function that we have also in Java. So I have to define here it dot. Suppose I have to filter all the values that are starting from A. So apple and avocado. So suppose I am writing here avocado, and here I am writing apple because I will also print them in sorted order. So it dot start with. So it will just check, it is defining here all the values in our list. So it dot start with A. So that means using this filter function, I am checking all the values that are starting from A, and I am filtering it. So I am filtering all the values out. And now this expression will return me all the values that are starting from A. And after that, suppose I am writing more lambda expression. So dot. So now I have to sort them by their ASCII values. So I can just write here 8. And it is not here sort by, it is here sorted by. And suppose I am writing here more lambda expression. Suppose I have to make them all uppercase. So what I will do, I will just use a lambda expression that is called map. So map means I can just manipulate these values. So what I have to do, so it is the original value. So it represents the original value. And what I have to do, I have to just make them uppercase. And after that, I can just use some other lambda expression to print all the values. So for each, using this for each, I can also print all the values of a list. So I can just write here for each value I have to print it. So that's it. So you can see, first of all, I am filtering all the values that are starting from A. So let me also write it in next line. So list dot, first of all, I am filtering all the values that are starting from A, avocado and apple, and then I am sorting it. And after that, I am mapping every value to their uppercase value. So avocado and apple will be uppercase, and for each value I am printing them. So this should print me. Okay, it is not here start with, it should be starts with. And let me check now. So you can see here it is printing apple, then avocado. So I should print them in another line. So print ln. So you can see how powerful these lambda expression are. We can just write these 4 lines and we are already sorting our list. We are filtering our elements in list, and we are also mapping our elements to make them uppercase, and we are also printing it using only 4 lines. And if we were just doing this thing in our Java language, then it will be around 20 lines. And now let me just show you the thing that makes Kotlin much safer than other languages, and that is here nullable type. So when I'm writing here this val s is string, and I'm writing here this, so it have some value abc, and this should be a var so that I can also change it in future. So first I'm printing this, print lns, and after that I'm changing the value of this s. So s is equal to some value, suppose xyz, and I'm again printing it. So first of all, in this line, we are defining a variable that is ABC and printing it. And then we are reassigning the value to XYZ. So it should print me ABC and then XYZ. Yes, it is. But this is a not null value. That means this S is a not nullable type. So it can never have a null value. So I can just use it everywhere. It will never give me a null pointer exception. But suppose I am writing here this null. So that means I am assigning a null value to this s, but it is this string is a not nullable value. So it will just give me a compilation error because this string is not nullable and I am assigning it a null value. Null cannot be a value of a non-null type string. So in order to tell our compiler that this can be null, so we have to write here this question mark. So that means now this is a nullable type. So now let me just check, and there will be no error. Also, this line will be redundant because we are never using it. So let us just create a use case here. Suppose I'm creating a variable a, and that will be also of type null. So this will be a nullable integer, and I am writing here 1. And suppose I am writing here another variable that is not a nullable type. So I have to check here if a is equal to b, then I have to do something. So let me make them equal. So initially the value of a is not null, but it is a nullable type. That means it can have a null value. So after that, what I will do, I will make this a as null, and I will check if a is greater than b, then I will do something. So in our normal Java language, this will give us a compilation error. Sorry, not compilation error. It will just give us a null pointer exception, because what we are doing, we are initializing this a value with 1, and that means this a value can be null. So we have to check all the safety precautions. So like in this case, a is having a null value. After that, we are checking if this null value is greater than 1 or not. So here in our Kotlin language, it will just give us a compilation error, and that is because we cannot just use here nullable type everywhere without making our checks. So let me just try to print this, print b. So I will just see what compilation error it will give. Okay, it is just giving us a different compilation error, and that is here operator call corresponding to a dot qualified call. When we are writing here a is greater than b, so that means it is calling this function a dot compare to b. So a is here a nullable type, and you can see here which is not allowed on a nullable receiver. So that is saying our a value is null, and we just cannot use some method with our null values. So that means there this a should not be a null. And how can we define that this a is not null if we know this? So we have to write here this. So this double exclamation mark. So using these, we are defining and we are saying to our compiler that this value is definitely not null, and we know that. We are explicitly defining this. So, but we know in this case, a value will be null, and we are saying it is not null. So it will obviously give us a null pointer exception. And you can say here it is. So this value should not be null. And let me just give some another example. Suppose I am writing here a function that receive a parameter, not null parameter. So I am writing here a function a of type integer. So you can see this integer, it is a not nullable type, and another integer b, and it is returning a plus b, and I am just calling this function sum, and I am printing it, print sum of a plus b. So it should return me 2. I am saying that a is a nullable type integer, but it have a value of 1, and b is also a nullable type integer and also 1. So it should print me 2, but it will not print anything. And you can see here, okay, we have to write here comma, so it will not print us anything. And you can see here that is a type mismatch exception, because we are defining here nullable type integer, so it will be a different type, it will be a separate type from integer. So it is a nullable type integer, and we have to get here not nullable type integer in our sum function. That is why here we have a type mismatch. Infer type as type of nullable integer, but a non-nullable integer was expected. So that is why we have to make here, either we have to also write here that this can be null, or we can just write here that this a value is definitely not null. So let me just check both the cases. So if we are writing here a is definitely a nullable type, okay, what is this? Is not allowed it on a nullable receiver. Okay, we cannot just write here a plus b because a can be null. We know that we are not passing a null value, but still we cannot just do this because a can be a null value. So instead, what we can do, we can just write here this double exclamation mark. That simply means this a value is not null, and we are saying that. So it will now just return us 2. So I hope now you understand the concept of nullability in Kotlin. So after this, let us just now move to next topic, which is typecasting in Kotlin. So how can we do typecast in our Java language? Suppose I have some integer here a, that is 2, and another long value, that is b. So I have to typecast it something like this, integer and then the value a. So using this, we can just typecast this a to a long value. But in our Kotlin, we have to do something like this. So first of all, suppose I have some value here. Suppose this value x, that is of type string, and I'm writing here this abc. And I have some another value that is here y, and I am not defining the type, or I can also define the type. That is totally your choice. So after that, I have to now typecast this x to y, and we know that they both are of same type. So in some case, if you don't know where the x is initialized or what is the value of x, you can just use here unsafe typecasting, and that is here x as string. So that means we are using here this as keyword, and this x will be now treated as a string value. And if it is not, then we will just get some exception. Suppose I'm writing here this, okay, not string. If I'm writing here integer and this integer. So now we will just get some, okay, we are getting an exception. That is here class cast exception. So that simply means we just cannot typecast this string into an integer. So it is not an integer. And suppose I am doing the same thing, string to string, string and string. And after this line, I am also printing this y. And suppose in any case we don't know the value of the x that was initialized somewhere else, and we have to safe typecast here. So what we have to do when we have to typecast safely, so that is here nullable cast, and we have to define here this, that as question mark. So that means this value will be null if the x is not a string. So if I'm writing here ABC and I'm writing here x is a string, so I'm expecting that x as a string I have to typecast it, and x as an integer. So also I have to define here this nullable integer, because if the x is not an integer, then it will just return me a null value, and I will just print a null. And you can see here. So this is here nullable cast operator, and this was simply called as cast operator. Okay. And there is also another way we can also check what is the type of this string. So what we can do is if x is string, so this is a is keyword that we can use, and it is also called as smart cast. Then what we can do is y is equal to, okay, we cannot just do here this because y is a value. So we have to define here this where, or let me just tell you one more concept. So here comes the need of our late init keyword. So in our Java and also other languages, we can write as this. So string a and then semicolon. That means we are just declaring and not initializing. But in Kotlin, that is not possible. Suppose I'm writing it as this. Suppose I'm just only writing it as this, where y, and that is of type integer. That will just give us a compilation error. So you can see, even if it is a value or if it is a variable, that must be initialized. So in our case, what we have to do, we have to say here, if x is a string, then y will be equal to x. And else we have to do something like this, x will be equal to none, no value. Okay. So suppose I have to do this thing, and we just cannot declare our y here. We cannot initialize our y here. We have to initialize it somewhere here. So what we have to do, we can just write here late init keyword. So using this late init keyword, now I can just say my compiler that I will just initialize my variable later. So, so you can just see I am initializing my variable here. Okay, that is of type integer. I have to make it string, and Now you can see we are just printing ABC because X is a string. So we are using here this smartcast and we are also using here this lateInit keyword. So suppose in any case we are not initializing this lateInit value. So what will happen? So this will just give us an exception. You can just see here uninitialized property access exception. So we are accessing this Y here and this was never initialized. So we are just getting an exception. So these were all the basic concept in our Kotlin language and now we will move to OOPS. So if you previously worked in any programming language, then you should know what is an object, what is a class. We are not going to discuss that here. We will just see the syntax. So how can we define a class in Kotlin? So we can just use here the class keyword and that is similar as other languages. So we can just define here a class shape and after that these curly braces. So here we can just write here this property of this class. Suppose I'm writing here var and size that will be integer and it is initially 0. So that is the basic thing we already know. So how can we write a constructor? So there are two ways. So either we can write here this constructor keyword. So that will be not our primary constructor. And we can just write here this. So suppose I am writing here some parameter size integer and this dot size is equal to this size. Okay. And let me just try it out. So how can we create instances of a class? So we can just write here val shape class equal to this shape. So we don't have to use here a new keyword like we have in Java. So we can just write it as this. So is this empty constructor means that we are calling a constructor from here and not this one. So if you want to call this constructor, then we can just pass here some parameter and that will be 10. And after that, suppose I have to print here something. So print shape dot size and it should print me 10. And you can see here. So this is very similar to the things that we already did in our other languages, but there is a powerful thing in our Kotlin that we don't have to do all these things. We can just write here this val or we can write here var also. So var size integer and that's it. So integer. And this will be the exact same thing what we were doing. So we don't have to even initialize these curly braces. So you can just see this is the exact same thing. And that class only contains our data. So we can also write here this is a data class. So like we have our plain old Java object Pojo classes and using this data keyword it will automatically generate all the getters and setters and also our toString method. So this is a very helpful keyword and we are also going to use this very extensively. But let me just write it simply. But there is a problem when we are writing it as this. We cannot just write here empty constructor. So if I am, then it will just give me some error and you can see no value passed as parameter. But if we want to write some empty constructor, then how can we write it? So we have to write here some default value like what we were doing in our previous case. So we were just doing here var size and that was initial value was 0. So we just have to define our previous value, our default value here in the constructor itself. So we can also write here in any method, any function. So suppose I have some parameter. Suppose in this main method I have the args, this array of string and I can just pass here the empty list. So that will be either we can just define here mutable list of or I can just define a list of. Okay, I have to write here array. Okay, yeah, that is obvious. It is an array, so I have to write here array of. So it will be just treated as a default value if we are not passing any. So that means I can just use this value, but you can see the difference. I'm writing here this simply variable name and then type, but I'm writing here this var and then the name and then type. So what does that mean? So this will be now acting as our field also and also our constructor parameters. So here it is just reducing a lot of our complexity. So what we were doing previously, so we can just write also simple constructor here, size integer, and we can just write here var size equal to this size. Okay, and this will be the exact same thing as writing var size here, and we also have to pass a default value if we don't have to pass any parameter in the constructor when we are creating instances of this class. Okay, so we can just remove this whole block and this will be the exact same thing. So I will also remove this and let me now just talk about the init blocks. So we can just use multiple initializer blocks in our classes and we are just gonna also use this extensively. So using this init keyword and after that defining a new block, we can just write here anything. Suppose I have to print here This is the first block. And after that, I will just do the same thing. I will just create another block. And these blocks are executed in the same order as they are appearing in the class body. Okay. So first of all, this block will get executed, and after that, this. So I will write here second. So whenever I am creating the instance of this class, then first of all, this block will be called, then this. And let me just check. So you can see first this block, then second block, and after that this 0, because after this, after instantiating this class, then I am printing this value, right? So that is why I am printing this. And now let us just talk about abstract classes. So if we have to create a some class abstract, so I can just use the exact same keyword, abstract, and after that we can just define some functions there. So using this, I can just define some abstract function here, create, and we can just use it here. So we can just okay, I have to define some another class. So if I am defining some random class, if I am writing only this class keyword, then this class will be treated as a final class. Okay, so we cannot override this, we cannot extend this class. So I'm writing a class here main, that will be extending this shape class. And as this shape class is an abstract class, so now I have to override this create method. So I will just use this override keyword. So we will just learn all about this inheritance and overriding overloading in later video. So now I can define this. So I will just print create function, print ln, and now I can just create a main class object. I can just create an instance of this main class, and that's it. Main dot create. So you can see here we are writing here create fun, and that is the same thing. We already know this thing from our other languages. So I just told you that if I am writing some class here, then this will be treated as a final class, and I am writing here abstract class. So this will be not a final class but a abstract class. So that means we can override this class. But if I want to override some other class, so class, I am writing here, suppose for example I am writing here rectangle, and this will be of shape class. So I am writing here shape class. So suppose I am writing the same property here, where size, that is here 10, and I also want to write some function that can be inherited. That means the function should be overridden, so I have to write the function as open. So if I want to also override this class, then this class should be also open. I just told about that. So I am writing here function, suppose I am writing here function size, and this is returning me size, return size. Or suppose I am printing here size, this is printing size. Okay, and now this rectangle class will just override. So it, suppose it also have parameter, suppose it have only parameter, not a property. So I will just write here size, that will be of type integer, and I can just pass this value to our parent class. So how can we write here? So this shape, and I can just pass here this size. So that means this size will be now just passed to our constructor of this shape class. And after that, I just can override this open function. So override function size, and I can now just use the property of the parent class, this dot size. So that means we will just print the size, and after that, suppose I have to print something else. So print ln. So I am writing, suppose here, first I am writing print ln size in shape. And after printing size in shape, then I am printing size in rectangle. And after that, again, I am printing the size. I will just create the instance of this rectangle class. Rectangle class, and I can just pass here a parameter. So let me just make it this, or I don't have to necessarily create it a property. So I can just pass here 10, and I have to call this size function, right? So main dot size. Let me just check it. So what it will do? Okay, we are getting compilation error, rectangle. So what it will do? Let us just check. So first of all, we are creating instance of this rectangle class, and we are passing 10 here. So after passing here 10, so we will be here and we'll just pass this value to our shape class. So this shape class will just print it here. And when it will print, when we are calling this size function, so this dot size, that means we will just print it here. And and it should print size in shape and then the value, that is 10. So size in shape and 10, and after that size in rectangle and then again 10. So it should print 4 statements. Okay, we are getting Stack Overflow exception. Okay, we are just calling here this dot size. We have to call here super dot size because we have to call the function of parent class. And you can see, first of all, we are calling size in shape. So this, and after that this line. That thing is only because of we are passing this size here in the constructor. Okay. And after that, we can just print both the lines here, size of rectangle and then size. So it is very cool and easy to use all these things in Kotlin language. And if we were just working in our Java language, then there will be a lot of boilerplate code. So same as this, we are writing here open function. We can also write here open properties like this, and we can just do the same thing here. And now let me just talk how we can create inner classes. So whenever we are creating a class, we can also create an inner class for this. So inner class and a rectangle. Suppose I am writing here square and then this. So that means we can just write some functions here. Suppose I am writing here fun and add. Suppose I am passing here two parameters, a of integer and b, and I am writing here print ln. So this is a void function. Void means unit. And the profit of creating these inner classes is that we can use the functions of this inner class in this rectangle class. So what we can do is, whenever we are creating a function, and we can just write here print. I will just write here double T so that we don't have any misconception. So what I will do here is, I will just get two parameters. I will just get here two values, and after that I can just call here this. Square square dot add, and I will just pass these both values and it will just print me. Okay. So in our main class, let me just remove this shape class. So in our main method, first of all, I will just create an instance of rectangle and I will just pass these two values, and I have to call print. So what it will do, first of all, we are passing two values. So a and b will be here, and after that we are printing. So we are calling this print function, and this print function is calling the add function of the inner class. So we will just be here add function, and it will print a plus b. Okay, right. Obviously, we just cannot use here these values. We have to write here where we can just write here property where. And now you can see we are just printing 30 because 10 plus 20 is 30. And we just cannot use here a plus b if they are here only parameters and not property. So if they are only parameter, so that means they will be only a parameter in the constructor value. So it will be something like this constructor. And if we are writing here a int and b int, so it will be something like this if we are writing here. So that is very obvious. We just cannot use this a and b here in this print function. So that is why we have to write here these vars. So we have to make it property of this rectangle class. So now you know how we can create classes in Kotlin, and let me just tell you how we can create interface. So how can we create interface? We can just write here keyword interface and then name. So my interface. And after that this body. So interfaces in Kotlin can contain declaration of abstract methods as well as method implementation, and that makes them different from abstract classes, right? So what can we write here? We can just write here some properties like var, or I can just also write here val. I have to write here val, and after that this is some property, and that can be any type. And if we are writing this, then this will be always abstract, because then we have to override this in our implemented class. Okay. And we can also write here getter and setter for some different property. So suppose property 2, and that can be of type anything. So suppose here string. So we can also write here getter and setter. If we are creating a data class, then it will automatically generate us getter and setter methods. But if we have to write here, then we can just define here this getter method for this property. So using this get keyword, we can just write here get a property of this. That means we can write here some default value, or if we want to get the value from some other sources, then we can also do it here. And after that, we can also write some functions in our interface that will be also abstract. So this foo method is abstract and we have to override into the children class. So let me also make the class here. So class, my class, and how can we implement it using the same double colon, my interface. And I will just show you what error we will get. So currently we are not implementing any method and we will just get a compilation error. So you can see my class is not abstract and does not contain, does not implement abstract member public abstract val property, right? So we have to override this value and we can just do it here. Override val property that is of type integer, and we can just set some value here. And now let us check. Okay, we also have to write here. Yeah, this function is also abstract, so we also have to override this function. So now everything will be fine because we are having the default getter of this property, and I think we should write something here. So what I will print my class dot, and I have to call this foo. And let me just check now. So, okay, we are first of all calling this foo function. That means we will be printing foo. And after that, this is printing what it will be printing. So this is returning us a unit value. And you know this thing, I already told you that if we are not defining any return type, then it will be unit return type. Okay, that is also similar to void in Java. So now we just learned about classes and interfaces, and let me just tell you about visibility modifiers. So what are those? We also have the same things in other languages, and that are public, private, and in a Kotlin we have a special one, internal, and after that we have protected. So these are the four keywords that we use for our visibility modifiers. And we also already know that classes, objects, interfaces, constructor, and functions, as well as their properties and also their setters and getters, can have these visibility modifiers. And what is the use of this public modifier? So if we already don't have any visibility modifier, then this public will be by default. So this function is also public, and if we create some class, so that class will be public final. Okay, and if you mark a declaration as private, then it will only be visible inside the file that contains the declaration. Okay, so that is the similar thing that we have in other languages. So what is this internal then? So if you mark it as internal, then it will be visible everywhere in the same module. So we will just working with modules in our Android. So what is this protected? Protected means that the member has the same visibility as one marked as private, but that it is also visible in subclasses. So after that, we have generics. So classes in Kotlin can have type parameters just like in Java. So we can also write it here. So suppose I'm creating a class here and I can just define the generic type here in these corner braces, that what is the type that this class will be working on. So what is this T? I have to now define this T every time when I'm creating the instance of this box class. So I can just now write here T, and after that I can also create some var here value that will be equal to T. Okay, so we will just define this value will just know runtime what is the data type of this. So when we are creating the instance of this box class, we can just write here box, and that is of type integer, and we can just pass here some value, suppose 1. So this value will contain 1. Or instead, what we can also do, we can just remove this because this is optional, and we know that this one is of type integer, and our compiler will just know that this is of type integer, so T is also of type integer. So now we just covered all the basic things like loops, conditional statements, syntax of Kotlin language, and also the important pillars of OOPS like inheritance, abstraction, and now you know all the concepts. Now you know the complete overview how we can use them in Kotlin. So now we will move ahead to multi-threading, and that will be using coroutines. So first of all, let us just see what is a coroutine and why do we need it. So suppose this is your application and there will be a thread of execution and that will be main thread. And we are here supposing that you have the basic understanding of multi-threading in any language, and we will just see how we can do that in our Kotlin language. So in our application, we will have our main thread, and on our main thread, we can just render our UI. We can just handle some mathematical calculation, and we can also handle our user events, right? And now suppose you want to do some heavy tasks. Suppose for example, you have to make a network call. So you have to do that on our main thread. And suppose you have to run some database query. You will also do that on our main thread. And suppose you have to load your image and some other task that you have to do. So if you do that on our main thread, then this thread will get blocked. And as you know, these tasks are heavy, so this will obviously block our main thread. And if our main thread is blocked for our long enough time, then our operating system will just shut down your app, and the data of user will be lost. So that is why we always have to use our main thread for the small tasks like this. And when we have to do some heavy tasks like network call or database query, then we have to create multiple threads. Then we have to create this background thread. So this is our first background thread, and that will just handle our network call, and we will just create another background thread that will handle our database query. This database query task will work on our this thread. That is our second background thread. And that means now we have to create multiple threads. Suppose we have n number of tasks, and then we have to create n number of threads for these. And you already know that threads are heavy. So if you are creating a number of threads, then they will obviously consume a lot of resources on your device, and this will make your phone hang. Or you can say the user will just experience lagging in your application. So we cannot just remove our threads because we have to do these tasks. So what we can do is we can just use here coroutines. So now what is a coroutine? So you can consider coroutine as a lightweight thread. So instead of creating multiple threads, you can just create one thread and use here coroutine. So coroutine will be something like this. You can create multiple coroutines that will work on one background thread, and your main thread will be clear. So this is your coroutine 1, this is your coroutine 2, this is your coroutine 3. And you can just make your network call on our first coroutine, database query on second, and image processing on third. And as you can see, they all are working in one thread, and that means resource consumption is also low. So Kotlin coroutines are very powerful, and as you can see, we are only creating one thread for all our heavy background tasks. So that means they are also helping us in optimizing our performance of application. So that is why we have to use here coroutine. But what is it? So what is the difference between a thread and a coroutine? So first of all, consider this coroutine as a lightweight thread, but it is actually not a thread. It works on a thread, alright? And they are totally not equal to each other. So remember that thing, thread is not equal to a coroutine, even though you can see they are doing similar task of doing our heavy operation on background thread, but still they are not equal. Also like thread can work parallelly. Also multiple coroutines can work parallelly and also can wait for each other and also can communicate with each other. So suppose there is one coroutine, it can also communicate with the values of another coroutine, and they can also share their result or the progress. Also, one important thing to notice that whenever we are executing a thread, so suppose this is our main thread and it is ending here. So our application will wait for our next thread to complete the execution. Suppose this is our background thread. So our application will not die when this background thread is running. So our application will only die when this thread is also dead. And that is not the case for our coroutine. So this is our one thread and we are running a coroutine here. So if this thread is dead, then this coroutine will also die. And there are also some scopes for coroutine, like for global scope. Global scope means the scope of coroutine will be for our whole application. That means our coroutine will die when our whole application is dead. And there are some local scopes, like for some application. Suppose this is our main screen, and after that we have some another screen. So this is our screen A, this is our screen B, and suppose we are launching one coroutine on screen A. So when we are navigating from screen A to screen B, so after that on screen B we are launching another coroutine. So when we are navigating from screen A, this coroutine will be dead. Well, actually that will depend. Either you have all the resources of this screen on your stack, or for further example, suppose we are at this screen and we are launching another coroutine, and when we are pressing the back button, so when we are at screen B and when we are pressing the back button, so this screen will be dead and this coroutine will also die, and we are back to this A screen. So that means our app always wait for a thread to complete, but not for a coroutine. So that was also the another difference. And after that, let me just tell you how we can create coroutine. So there are three coroutine builders. So the first one is launch coroutine builder. So launch coroutine builder, and how can we create one? So we can just use here these curly braces, and inside this there is a now coroutine scope, and we can just write our background task here. So inside this, and when we can use this keyword, so we can just access coroutine scope. So let me just write here coroutine scope. So every coroutine, either it is the parent one, or we can also launch here nested coroutines. So suppose I am launching this. So this launch is our parent coroutine and this is our child coroutine. And we can just do something here. We can just print here. And this child coroutine will have its own coroutine scope. And this was the first coroutine builder that is launched. And after that, we also have the second one, which is async coroutine builder, and it uses the same thing, but this coroutine also returns something, and that is here this async function return as a deferred object, and this launch function return as a job object. And so I will just write here like this. So it will return as a job object. So it will be of type job, and using this job function, using this job object, we can just manage our coroutine, or we can just control our coroutine. So that means we can wait or we can cancel our coroutine using this object. So same as this launch function, this async function also returns something, and that is your deferred object. So it returns value of deferred job, that is of type deferred. And using this deferred, we can also return some value from our async function. Suppose after doing some background task, I want to return something, and I can just use this async coroutine builder to return the values. So suppose I want to return some integer, and that means at the end of this block, I will just return the integer value that I have to return, and this deferred will be of type int. Okay. And that was the second type of our coroutine builder. And after that, we also have the third one, and that is called as run blocking. And as the name suggests, it runs on our main thread and blocks our UI. Okay. So these are the three main coroutine builders. There are a lot of things to cover in coroutines that we can make a separate video on this, but this is not a coroutine video, so we will just see them when we were using it. So after that, there is one more thing that you should know, that when you will be creating projects on Kotlin, you will definitely get a keyword, this suspend. So any function can be a suspend function. If you see this thing, that suspend function and then your function name, so that means this function is a suspending function and it should be launched inside of a coroutine scope. So that means you cannot just write this function inside anywhere. You have to only call this function inside of a coroutine scope, so that the task inside this function can run on a background thread. And I think that was all the basic things about coroutine. And now let us just move to the next topic. So our next topic is exception handling in Kotlin. So how can you just handle an exception? So like we did in our Java language. So there is this try block and then this catch block, and we have some value here that is the exception that we are gonna get. And I'm using this exception class, that is the parent class of all the exception. And then I can just print here some value. So suppose I am writing here exception occurred, and after that we can have a finally block like we have in our Java language. And I can also write here some things finally here. And suppose for example I am creating an exception here, value a is equal to 1, value b is equal to 0, and value b is equal to 0, and I am doing here division by 0 exception. So what I will do, I will just write here val c equal to a by b, and I'm trying to print c. So what it will do is it will just return division by 0 exception, and we will be here. So you will be definitely using this exception handling in Kotlin. So you can see here exception occurred, and at last we are doing this print finally. So if you want to catch some more exception, like you have the type of exception, then you can just write here multiple catch blocks. So suppose I am writing here null pointer exception, then I will just print null, or I have to print ln here. I will also do print ln. So what I will do is I will just create it a integer nullable type, and here I will do a is equal to null. Let me just write here some other things. I will just write here a condition if a is less than b. So this will just give us a null pointer exception when we are writing this. So a is null, and we are saying here that a is definitely not null using this double exclamation mark. So this will give us a null pointer exception. Let me check. Okay, here we are reassigning the val. Instead, what we can do is we can just write it as null, and we just have to print this. Print a double exclamation mark. That means a is not null, but we know a is null. So we will just hit an exception. And you can see here exception occurred and we are finally here. Okay, this is not hitting a null pointer exception. It is hitting this exception because obviously this exception is the parent of all others, and I think we should remove this. And let me check now. So you can see here now we are falling in this block and it is printing null pointer, and finally we are here. So that is how we can do exception handling in Kotlin. So now let me just tell you about some important DDL and DML commands of SQL that we will be using while working with databases. So we will be using this DDL data definition language and DML data manipulation language commands. And the important ones that we will be using are this create, insert, update, and delete. So all these five are the main important commands that we will be using. And when we are querying data from our database, so we will be using this select command also. So these are the five important commands that we will be using. So first of all, let us just see what is this create command. So in our Android, we will be working with SQLite, which is the lighter version of SQL. And these are some of the important commands that we will be using. And don't worry, you don't have to remember all of these. We will be just using room. You can consider evolution of SQLite. So we will be using SQLite under the hood, but it will be in the form of room database. So we will just talk about that when we will be using it. So first of all, this is our first command that is used to create our database. So SQLite 3 and then database name .db. And you have to try any of them. You can just write it in your command line if you have SQLite 3 installed. So after creating our database, now we have to create our table. So you know in our database, we can have multiple tables, and for creating one table, we can use this command create. So this is a data definition language command. So create, then table, then we have our table name. And and after that in our parentheses we can define our column and then type, and we can just define multiple columns separated by these commas. And after that, don't forget to use this semicolon at the end. So after this command we just created our table, and now we have to insert some values. So for inserting we have this insert command, and insert into and then after table name, because we can have multiple table in our database. And after that we can just use the same syntax. We can just define here column name, and after that we have to define here values that will be also separated by this commas. And after inserting, so after this line we just inserted all the values, and you can see here we are inserting values one by one. And after that we have to query. So this select is a data query language command, and after that select and then the column name that we want to select and from our table name. So we have to select some particular column. So suppose this is our table and we want to select only the values from this column. So what we will do, we will select how many number of columns that we want to select, and after that the table name. So this was the command to query in our database, and after that we can also update our values. So for updating we can use this update command, that is data manipulation language command. So update, then table name, then set. So set means now we have to set some value. So what value do we have to set? We have to select this column value equal to this, and we have to define for some rows. So obviously we are not setting the values of all the rows. So we have to select some particular rows. So suppose there are three rows, 1, 2, 3, and we want to only select this row. So we only have to update the this row value. So what we will do, we will just write some condition where id is equal to 3. So we can just use here primary key or any other column. So we have to also write here condition when we are updating some value. And now after updating, if you want to delete some value in your database, in your table, then you can use this delete command. So delete, this is also data manipulation language command, delete, and then from, now we have to define our table name. From which table do we have to delete the value, and where, and then condition. So which row do you have to delete? So you have to write here the condition for this. You can just write here where id equal to 3. So we will just delete the row that have the third id. Okay. And after that the last command that is used to drop our table. So this is a heavy operation that will entirely delete our whole table. So our table can have multiple values, it can have multiple rows, multiple columns, and after using this drop table command we will just drop our entire table. So this table will be removed. And these are all the commands that you have to know. You don't have to remember all of this because we will be not using them directly, but they will be working under the hood when we were using some functions. So now let me just show you how we can install Android Studio. So why we are installing this? Because we need an integrated development environment for creating our Android application, and that will be Android Studio. So you can just write here Android Studio, And after this, here is the first link that will be of this website, developer.android.com. And when I'm making this video, the latest version is Android Studio Electric Eel. So you can just come to this page and click on download. So after accepting all the terms, you can click here. So it is around 1 GB and it will obviously take time to download. So now the download is completed and you can just click on it. So after this, just click on next. And I also have the Android Studio, and you can also check this Android virtual device. So either you can just use your physical device and you can just connect it with USB cable, or you can use here a Android virtual device. So I will just select this and next, and it will be installed here. So for you, it will be showing here Android Studio, and for me, it is showing here Android Studio 1 because I already have one version installed. So just click on next, and after that, just select here install. So it will just take time, so be patient. So after this, click on next and you can just finish. So now it will launch. So you will be here at this page and I already have so many projects. So what you have to do, you have to create a new project. And after that, you can just select here this basic activity, or if you want to just go with Compose. So Compose is the UI toolkit for Kotlin and you can just select this. But with our course, we will be just using this basic activity. So click on next and here you can just create your project using this finish. And don't forget to select this Kotlin as your language. So consider this video as lecture 0, and as now you know the preferred language for Android development. So just go install Android Studio and start your development journey, and I will see you in the next video.